All yours, Philippe.
All right, thanks, man. Thank you all for joining. I'm not going to repeat what Mahmoud already said. My name is Philippe. I was trained originally as in theoretical physics before finding refuge in philosophy, and I always get asked this question: how do you do that? How did you end up in philosophy? As if it is a bad thing from a successful graduate studies in physics, tech, the future, all that rap, to the humanities department where nothing good ever happens. So and actually it was actually my studies in physics that pushed me into philosophy. I'm going to try to make this clearer today, because I think, in my opinion, what's going on in physics today, by physics today, I mean contemporary theoretical research. I'm not talking about technology, etc. And this new anti-philosophical attitude, this scientific attitude that we see in scientific, or precisely physics circles, is bad for the discipline itself. It's bad for physics, and the other way also works. I think that the dismissal of science and physics in particular in some philosophical circles is very, very bad for philosophy. So it's kind of a call for a more scientifically informed philosophy and a more philosophically informed physics. So I hope I can convince you why I think this is important, and why I think this is very, very relevant to what's going on today in both disciplines. So we call the talk a call for peace. Actually, the clash between physics and philosophy is not actually very well known today. There are a lot of philosophers of physics, so it's not everywhere that you see this clash. But still, we have a lot of popular science books bashing philosophy, theology as being over, as being dead, as being dumb. And this is mainly the issue that I'm going to be addressing. So I'm going to talk about why I think that a dismissal of philosophy is bad for physics. And then I'm going to talk about why a dismissal of physics is bad for philosophy. There you go. So we'll make it quick, as simple as possible. Then maybe we'll have the time to talk about anything you guys think is interesting. So the dismissal of philosophy, metaphysics in particular. So metaphysics, the study of the most fundamental structure of reality, the study of what there is, of what the universe is made of, beyond what our best science can describe. It's a very, very old problem. It started a long time ago, possibly with Hume, who famously said that any book containing metaphysics and theology, we should commit it to the flames, because it contains nothing but sophistry and illusion. Hume had a whole argument about this. He wasn't scientistic in spirit. He was defending his empiricism, a radical empiricist way of doing philosophy. So I'm not saying that Hume was anti-philosophy or anti-metaphysics, but this idea that metaphysics should be replaced by a more empirical kind of philosophy, meaning science, is very, very old, starting from the 16th, 17th century. So the other quotes that you see are very contemporary. I won't let you guess. I'm going to spoil them very, very fast. Early 20th century, the logical positivists, this bunch of nerds that think that they can radically eliminate metaphysics on scientific grounds. According to them, the only way to find out what there is by studying physics and empirical science. So for them, metaphysics is not sophistry and illusion. It's not even wrong, because for them, metaphysical works, they contain nothing at all. They're completely meaningless. And again, the Hume, the positivists after him, they had at least very, very elegant arguments. Some might say they knew their science. The positivists, at least, they were all mathematicians or physicists, scientists. They knew their philosophy. But today, what's going on is much, much worse, because you have very, very important scientists bashing philosophy, declaring that philosophy is dead without even knowing what philosophy is about, and in particular, what philosophy of science is about. Philosophy is dead. It's very, very famous. That's Stephen Hawking writing 10 years ago, one of his books, The Grand Design, if I'm not mistaken. He started declaring philosophy as being dead, and the torch has been passed on to the scientists now that are going to discover how the universe actually works. Steven Weinberg, before him, these are immense physicists. He had a whole chapter in one of his most famous popular books, Dreams of a Final Theory. It was called Against Philosophy, in which he actually thinks that philosophy is bad for science. It's not even unnecessary. The champion of scientism, the last quote, Neil Tyson. These people have a huge influence on young people that are interested in science and wanting to study science. Well, for him, everything we learn from contemporary physics has made the armchair obsolete. Reducing philosophy to the armchair, people pontificating about what should be done, that's not what philosophers of science have been trying to do. So these physicists that are very, very respectable, some of them at least, I'm not going to say which, they really know how physics works, and they have a lot of influence on future students of science and on everyone else, taxpayers, right? People who are actually paying for research to get done. But the problem here is that they are declaring philosophy as being dead, and they are declaring philosophy of science as being completely obsolete and unnecessary, without even knowing what philosophy of science is about. Philosophy of science is not about telling scientists what should be done. It's actually about trying to figure out what science is, how science works, in order to be able to make some sense out of it. Because we all agree that science, physics in particular, it's an essential part of our modern world, if we're sticking to technology, etc. And it is ridiculously powerful, predictive. It gives us results. It makes lighter. Some might argue it works. So from a completely pragmatic point of view, science did a lot of progress, and contemporary physical theory is actually ridiculously predictive. I'm going to talk about this in a couple of minutes. So there is something about science, and what philosophers of science are trying to understand is what makes science so special. Because this naive way of looking at science that you'll find in every high school physics textbook, the scientific method with a uppercase S and M, you start with a hypothesis, you come up with some kind of explanation, you test it, it's all about testing, experiments, etc. a very quick look at the history of science and the development of the history of science is enough to tell us that this scientific method, it doesn't exist. At least it doesn't exist in the form that these textbooks are pretending it to be. It's not that easy. The history of science is so complicated, and it's not only about empirically testing hypotheses. There are some of the most famous periods in the history of science that came about in a radically different fashion. I'm talking about the Copernican revolution. The history of this period today has been changed in order to fit the narrative that some scientists want to sell. We actually change the history of science. We come up with experiments that never happened. We downplay the importance of Galileo's Platonism, for example. We downplay the importance of Newton's very weird ideas about substance and about God. We downplay the importance of Kepler's mysticism in order to make the history of contemporary or modern science look more like what we actually want it to be. So a very quick look at the history of science, modern science at least, tells us that if there is scientific method, we're not very sure that it's that easy to describe. It's much more complicated than that. And why is this important? Because if you discard these philosophies of science, you would actually be saying that there is one particular scientific method that every future scientist have to follow. And you would actually be disregarding the most important aspect of science, in my opinion, because the power of science, what makes it so successful, is its flexibility, right? This propensity to change and to modify its own methods and to modify what making science even means, what doing science even means. This is the particularity of science, and this is what makes it so powerful today. So disregarding its history, its modern history at least, is very, very bad for the discipline itself. Because today, especially in theoretical physics, with everything that's been going on for the past 40 years, string theories, going beyond the standard model, etc., you'd have this very nuanced debate about whether we are doing science or not doing science, etc., etc. So a quick look at the history of science and physics in particular tells us that this problem always existed, and a lot of people try to make sense, probably in vain, of the history of science. But it might be interesting for physicists to take a look at the history of their own discipline, in order to understand how scientific discoveries are actually much more complicated than what we make them to be. And it would help us or prevent us from going down that slippery slope towards scientism and actually thinking that every kind of statement doesn't have any kind of value unless it can be tested empirically. Again, we shouldn't stick with the armchair, thinking that science is only a rationalistic enterprise. Neither should we go towards the other extremes by only talking about empirically testable hypotheses, etc., etc. This new exaggerated scientism that is, in my opinion, much worse for science than what it is for philosophy. So yeah, but that's not new. The debate has always been here, but it has been losing its philosophical depth throughout the years. So this anti-philosophical stance that a lot of scientists that you can find probably all scientific circles today, is due to a misunderstanding of the way science works. Because again, if we look at the history of science, we would see that what we call science is something that is much, much more complicated than what we think. Is it as it's different than it's probably different than all other disciplines, academic disciplines. I agree. There is something about it. It can make predictions that are sometimes that correspond to reality to a ridiculous degree. I'm going to talk about this in a couple of minutes, but that doesn't mean that it has a very particular set of methods that are at the same time descriptive. They can describe how science worked until now, and prescriptive in the sense that there is only one way of doing science. If we do not follow it, we are not doing science, and whatever it is that we are doing shouldn't even be considered as a respectable scientific research. So yeah, this is what, especially with the way science works today, peer-reviewed journals, all these politics and shit. I think it's very important to better understand the history of contemporary science in order to probably to make things better today. So this anti-philosophical attitude in science is not absolute. There are a lot of philosophically informed scientists that think like the early 20th century physicists, Einstein, Bohr, Schrödinger. These guys, they knew their physics, obviously, and they actually took the time to try to understand what their scientific theories are telling them about the world. So Paul Feyerabend used to call them the physicists philosophers, and he would qualify the guys that came after them as savages, uncivilized savages, because they were very, very technically efficient, the Feynmans, the Schwingers, etc. But they lacked the philosophical depth that the titans of modern physics possessed. So I'm going to talk about this in a minute. I don't quite agree with him. Richard Feynman was very philosophical, even though he did not. He wouldn't agree with me. He always bashed philosophy as being as useless to ornithology as ornithology is useful to birds. But actually, he wrote a lot of books about the nature of scientific discovery and the nature of physical theories that are very, very profound. Anyway, so this anti-philosophical attitude in science is very bad for science itself. It leads us to scientism, which is a no-no. But let's not forget that there is a...
why is it a no-no?
Scientism?
Yeah. It's like you said it as though it's, it's a clear answer.
It's
not so sure it's very clear to others.
It's not. Some would preach scientism today, considering it to be a badge of honor. But there is a difference between the scientism of the positivists that think that any kind of rational discourse about the nature of the world has to be scientifically informed. This kind of scientism, I'm totally on board with it. I really believe that we can't do metaphysics today without taking into consideration the empirical discoveries of the sciences, at least until the early 20th century, in physics, in biology, in the neurosciences today. But this blind scientism that would judge any kind of discourse that is not scientific, whatever that means, as being completely irrelevant, this is a no-no for society and for science. Actually, if it's bad for society, eventually it would reflect back onto science, right? Because you go back to this misinformation, taxpayers not wanting to fund science anymore. What are we making of science? And this actually happened in the States in the 80s, when the Americans wanted to build the biggest particle collider ever conceived. It would have shamed the LHC that we have in Europe today. It was 3 times as big, and it was to be built 30 years earlier. So, and the plans were there, they were actually working on it. But since it cost a lot, you had these voices that were opposed to it, then it passed through Congress, etc., etc. Long story short, it actually got canceled because there was this kind of disinformation between the scientists and the public. What the hell are you trying to achieve with all this money? And the scientists, the scientific scientists were like, okay, you guys wouldn't understand. We want to understand the fundamental nature of reality, or we want to take a look at what the universe looked like when it was very, very young. So this is what I mean, that when you have a bad picture of science in society, it would actually reflect back to on science eventually, in one way or the other. So
before you continue, what is an example of bad scientism? Bob is asking.
Well, the kind of this wave of new atheism that you have today. I'm not defending religion or whatever, but I'm saying that you have this new trend of trying to prove that religious belief is ridiculous because science actually gave us the answer to everything. This is very, very bad scientism. And you can take a very concrete example. There was a book that was written by an American cosmologist, Lawrence Krauss, called A Universe from Nothing, in which the author wanted to prove that science, physics, cosmology in particular, actually demonstrates how the universe we know came from nothing. And the ultimate argument was that philosophy, religion and theology is dumb, and how can you still believe in God in the 21st century, etc., etc. Then you have this philosopher of physics called David Albert that wrote a very good critique or review of the book in the New York Times. I actually urge you to read it. It's called I don't know. It's the review of the book, in which he shows how little the physicist, his understanding of concepts of nothing and origin, etc., were completely wrong. So this is a very clear case of bad scientism, actually saying things that science does not do and trying to sell them in a very, very simple fashion. I don't know if I answered your question, Robert. Name of the book, it's A Universe from Nothing. It's fun to read. It's popular science, but the message is not. It's bait and switch. You're there to exactly. I agree with you, Robert. So did contemporary physics answer the age-old question about why there's something rather than nothing? Of course not, because the question is not to demonstrate that a quantum vacuum, if you have a quantum vacuum, a universe eventually will pop out because the laws of physics imposes on it to be unstable. But the question is not why is there something in the physical sense rather than nothing. The question, the philosophical question, is to know why there is something, and physical laws are something. The fact that you have a universe that obeys to what we call physical laws is already something. So so saying that philosophers have spent, they're all idiots and they have spent 2,000 years thinking about questions that are completely ridiculous is ridiculous in itself. Yes, I agree with you, Andre. All scientism looks bad. Yeah, but if you take a watered down scientism, wanting to because the scientism of the positivists at the beginning of the 20th century, maybe without knowing it, but it gave us a revival of metaphysics that is very, very interesting today, what we call scientifically informed metaphysics or analytic metaphysics, in which we are trying to ask very old metaphysical questions about the nature of space and time and reality through the lens of new scientific discoveries. It's not reducing metaphysics to science, but maybe rethinking metaphysics and philosophy today through the I don't know, through the lens of new scientific discoveries. And this is what I'm getting at right now. So because we've been bashing anti-philosophical scientists, but let's not forget that there is also an anti-scientific attitude in philosophical circles. Some philosophical circles, it was very en vogue in the 20th century, especially in continental circles, influenced by Nietzsche, Heidegger, etc., according to which what science tells us about the world doesn't count. And Heidegger famously compares the botanist's flower to a flower that someone else would actually look at. And well, this is a very old example about the difference between how we see the world, how we humans, with all our problems and our freedom, etc., see the world, and the world that is described by science, that is very materialistic and mechanical, etc. So there was this anti-scientific attitude that was very, I don't know, it was on display in some philosophical circles, and in which actually ignorance of science was to be exhibited with pride. And this is also very bad, because I think that today, especially after the scientific revolutions of the 20th century, so in physics, relativity, quantum mechanics, cosmology, in the biological sciences, neurosciences, etc., and actually bashing science as being very far from being able to tell us anything about ourselves and the world we find ourselves in, is very wrong. Because if we take the time to look at the meaning, or try to understand the meaning of scientific theories, we would find that there is a lot of philosophical insights that are hidden there. Can you still talk about the philosophy of mind, the nature of mind, the relationship between the mind and the brain today, without taking into consideration all the cutting edge research that is going on in neurosciences? I don't think so. Yeah, exactly. Thank you, Nadim. I totally agree with you, because, and this is the other extreme that we want to, that I think is very bad for science and for philosophy. There is a social or a sociological side of scientific research, that's for sure, because scientists are human beings. But going as far as saying that every scientific theory is a social construct, and all that rap, is also very toxic, as you said. Thank you very much. Yes. So I think that I'm not going to talk about neuroscience. It's not my thing. I'm going to talk very quickly about 3 or 4 discoveries from modern physics 100 years ago that are, in my opinion, philosophical gold mines. And if we take the time to look at what they really mean, we don't really know what they mean until now. But if we take the time to try to understand what they tell us about the world, it can be very interesting for philosophers and scientists alike, because there are a lot, especially in popular science books, there are a lot of I don't know, weird metaphors when we try to explain scientific theories. The twin paradox, time going slower if you move faster, Schrodinger's cat that is both dead and alive. These are all bad metaphors, and they should tell us how philosophical modern physics is, because whenever you try to put your equations into words, you're gonna get sucked into this whole knot of misunderstandings, because it's actually, when you try to think about what physics is telling us about the world, it's actually very hard to explain without the math. And this is why I think we need more philosophically inclined scientists. Exactly, that's the review. Thank you, Jeff. It's the perfect example of good philosophy. I really urge you to read it. And ironically, the guy who wrote it, David Albert, is a physicist. The guy is a is a physicist who specializes in philosophy of physics today, and he actually destroys the book, and he destroys this whole idea of new scientism a la Dawkins and Krauss, etc., etc. So if you guys have 5 minutes after the talk, it's a nice place to start, and it gives you an idea about what philosophy of physics or philosophy of science is all about. So let's talk about some philosophical lessons from physics that should be interesting for everyone, and philosophers in particular, because whenever we talk about physics today, be it relativity, quantum mechanics, cosmology, statistical mechanics, etc., etc., there's this preconceived idea about what science should be. And that's what I meant when I said earlier that we don't even know what it is, because what science is, or what science should be, or the relationship between science, humans, and the world is not clear. And here you have two titans of modern physics, Bohr and Einstein. Tomorrow is Einstein's birthday, so we chose a good date for our talk, Mahmoud. So this picture is taken from the very famous debates between Bohr and Einstein. Again, philosophical landmines. They were debating the nature of quantum mechanics, etc. I might talk about this in a minute. But these two scientists, both of them, they made tremendous advances in modern science. Their ideas of what science is or what science should be, they were very different. They did not even agree on what a scientific theory actually is, or what a scientific theory should be able to do. So for Einstein, who was a realist, that's a very fancy philosophical term today, for him, the job of scientists, or the point of science itself, is to describe the world independently of observers, us. For him, nature is nature. It doesn't care about our existence in it, and physical laws are always observer independent. But Bohr had a radically different conception of science itself. For him, science is only about what we can say about nature, not about nature itself. This might seem to be a secondary problem, but it's not, because these two world-class titans of physics disagree on what physics is. For the first one, it's a description, an observer-independent description of physical reality. For the second one, it's more instrumentalist. For him, physical theories are tools that we have that will let us say things about the world and work with our experimental apparatus, etc., etc. But does quantum mechanics, that was in big part developed by Bohr himself, does it really describe nature as it is? For Bohr, you can't even ask this question, because science cannot answer this question. Science, physics in particular, is not about describing the world. And that's that's an extreme position. So, and philosophers, they have been debating these questions for a long time. The debates between the empiricists and the rationalists, the skeptics, etc., 16th, 17th century. The concepts or the terms of realism and anti-realism and instrumentalism already existed in the philosophical literature. But here, having these two titans of physics actually discussing the nature of science and its relationship with the nature of reality and the world is beautiful. And we cannot say today that Einstein and Bohr are secondary physicists. These guys were titans, but at the same time, they took the time to try to understand what their physical theories are telling them or not telling them about the world. Are these debates settled? Do scientific theories settle philosophical debates? I don't think so. London and Bohr, physicists who were talking about the philosophy of quantum mechanics for the first time, maybe, famously said that physics can only make negative philosophical discoveries, in the sense that they might not tell us, they might not settle philosophical debates, but at least they can tell you which philosophical positions are untenable. And that's the beauty about it, because we can still talk about the realist, anti-realist debate that modern philosophers in the 16th and 17th century discussed, but we have it here in a completely new light, because Bohr and Einstein were actually discussing quantum mechanics, this radical new theory about reality that doesn't make any sense if you try to put it into words. If you try to ask yourself, what does quantum theory tell me about the world? It would say things that don't make any sense, not only to a scientist, but to any human being. And you see that the problem here wasn't only about the physics involved or the mathematics involved, because it's a clear theory. It's very powerful. It's the origin of every contemporary technology there is. But the problem between Einstein and Bohr was that one thinks that this theory is incomplete in the sense that it is not a physical theory, because it can't possibly describe the world. But for Bohr, that's not the point of physics itself. The point of physics itself is to tell you what can be said about the world, not describe the world as it is. So here you have, and Mahmoud knows this maybe much better than I do, but if I don't say Einstein and Bohr, you'd think that this is a typical philosophical debate between two classical philosophers between British empiricists and continental rationalists, etc., etc. So taking a look at what was going on during the 30 first years of the 20th century is again, it's a philosophical goldmine. So let's talk a little bit more in details about three philosophical ideas from modern physics. Then we can discuss them if you guys are interested. The first lesson from relativity, both theories developed by Einstein, 1905, 1915, this radical theory of space and time, the fundamental question of philosophical question of relativity that Einstein wrote a lot about actually himself was about the nature of space and time. And maybe probably one of the oldest questions in philosophy. We know that Zeno talked about this question. Parmenides, Zeno and Parmenides are pre-Socratic philosophers, so we're talking 600 BCE. They ask questions of the kind: what is the nature of space? Is space a container that exists independently of things, or it's the other way around? You have to have things in order to be able to talk about spatial relationship between them. And the beauty about this debate is that, again, it existed ever since the ancient times. Everyone talked about it, the pre-Socratics, Plato, Aristotle, etc., etc. And with Einstein's discovery of the theory of relativity, Newton talked about it, Leibniz talked about it. Newton was a substantivalist. For Newton, there is an absolute space. Space pre-exists objects. When you have objects, you are actually talking about objects or events that take place within space. It's kind of a container. It can be empty. It can be full of things and events. For Leibniz, on the other hand, it was the other way around. It's kind of like he was a relationist. It's kind of, I don't know, like the alphabet. There is no alphabet unless you have letters. There are no family relations unless you have individuals that somehow have family relations between them. So this debate started with the pre-Socratics. It took a different kind of turn with Newton and Leibniz. You know, Newton developed classical mechanics. He talked about absolute motion, absolute space and time, etc., etc. Leibniz even used theological arguments to defend his relationalism, because if space pre-existed, why would God have to choose between creating the universe here and there? Very, 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 very profound philosophical insights. And this debate is still at the forefront of philosophical research today within the scheme of relativity, special and general relativity, because Einstein, when he was developing general relativity, he actually had a philosophical position in mind that he wanted to defend. He wanted to defend Mach, who was, according to Einstein, he was some kind of relationist. For him, he wanted to do away with absolute space. But the interpretations of relativity today tell us that it's not really the case, because there's this underdetermination between theory and philosophy. Well, because some would think that relativity is a relational theory. It tells you that space doesn't exist in itself. That was the classical view until one physicist, mathematician, De Sitter, actually proved that within relativity you can actually have an empty universe. He actually proved this mathematically. See what's going on here? You have a scientist, a mathematician working within the framework of a theory, actually proving something that is scientifically interesting, but at the same time, it has very, very deep philosophical consequences. Because we used to think, Einstein himself used to think that his theory tells us that there is no absolute space. It doesn't make any sense to talk about space if there were no things in space. There's no such thing as an empty universe. And Einstein had scientific considerations, but of course he had philosophical preconceptions, religious preconceptions. He wanted a static universe, etc., etc. But here you have a scientific, a mathematical discovery, De Sitter's discovery of the empty universe, that actually have very, very profound philosophical implications, because we were back to square one. Because you can actually, we do have substantivalist interpretations of the theory of relativity today. So did it settle the debate? No, but it gave us new tools to maybe to better understand the relationship between objects and space itself. Beautiful. So De Sitter, Willem De Sitter, he's a Dutch mathematician and physicist. He actually worked, because Einstein's field equations of general relativity are very, very complicated. We did not have all of their solutions. So he worked out a solution. He actually demonstrated that an empty universe actually can exist within the framework of general relativity. And when you say empty universe, you mean maybe, what does it mean, empty universe? It's an empty space, so space without objects. How is that possible if you're relationist? So there you go, classical philosophy 101. But not, maybe, but it was actually a physical universe, a physical universe that was empty. So exactly, when you want to put it in words, it's not this metaphysical or mathematical thing. It's actually a universe that has curvature without it having things in it. So maybe we can get to that in a couple of minutes, because there's the question of time. Again, events, same questions, Zeno, Parmenides, the pre-Socratics, Plato, every classical philosopher talked about this: time, events in time. What makes the present so special? Is it different from the past? Can we talk about future events, etc., etc.? Relativity also gave us a lot of things to discuss related to the debate about time, because again, the classical reading of relativity today entails a philosophical position that is called eternalism, that is philosophically very elegant, but existentially it is not, because according to this position, future events already have some kind of existence. So this was the philosopher's dream before Einstein. Eternalism was regarded as being some kind of wild philosophical theory, according to which future events already have some kind of existence. Parmenides and Zeno actually defended this point of view, the block universe. 600 BCE, then you have a scientific theory, two theories actually, 2,000 years later, vindicating eternalism by saying that the only correct philosophical reading of space and time according to relativity would be eternalist. And if you agree with this, you have a whole other set of philosophical problems that comes with, because saying that the future already has some kind of existence, you're stuck with all the problems about free will and agency, etc., etc. So again, you're jumping from a scientific theory that is empirically very, very well tested. I can't even begin to tell you how scientifically I don't know, the empirical foundations of relativity and quantum mechanics are ridiculously strong. So you're going from an empirically tested scientific theory to all this debate about future events and free will, etc., etc., etc. So this is what I mean by a scientifically informed philosophical discourse. So talking about space and time, because it's important, it's fun, but at the same time keeping in mind that there is a scientific theory that can tell us a lot of things that we didn't even think about on this particular debate.
Can I ask a quick question about?
Yes. Yeah, please do.
What ethical requirements should there be on say the scientific, the scientist who's writing a paper to go back in the literature and credit Zeno, for example? I mean, just to mention as a, based, since that is outside of science, theoretically, right? It's philosophy, pre-scientific. So is there something is that one of the things that should be compelled, is that you should hark back to those people, even if you say it's all empty? Is that?
Well, the problem is, Jeff, is that these kinds of questions, they are not being published in scientific journals anymore, because they invented this new academic field that we call philosophy of physics. No one knows whether it's philosophy, because some papers are very technical. No one knows whether it's physics, because the paper, the journal name would be something like Journal of the History and Philosophy of Physics. So philosophers of physics do always mention Zeno, Parmenides, etc. So they always frame these debates within their historical context, historical and philosophical contexts. But in physics, we do not. Physics is a very ahistorical discipline today, right? That's how we teach it, and that's how we were taught. Today, when I want to learn about Newtonian mechanics, I wouldn't read Newton's Principia, right? I would read a textbook written in 2010 that describes Newton's mechanics. So I don't know if I answered your question, but
well, yeah. I don't know. If you're just going to the moon, then Newton's fine. Exactly.
I do agree. And you might not want to waste your time trying to figure out what does this theory tell you about the nature of space and time, etc., etc. But what I'm trying to say here is that you can't pretend to be doing good philosophy, whatever that is, about space and time, about consciousness in the case of neurosciences, without at least taking into consideration the implications of our best theories of space and time today. Yeah. So another beast. This is the discovery, the development, discovery, I don't know how to put it, of quantum mechanics was very, very revolutionary. It's relativity. Philosophically, the revolution introduced by quantum theory, the revolution introduced by relativity is nothing compared to that of quantum theory. I can't talk about this today. Right now, it would take us a whole course. There is actually a whole course about this. There you go, Mahmoud, in July. But let's say that there is a lot of nonsense out there being said about quantum mechanics. And I'm not only talking about the quantum consciousness and quantum healing kind of shit. I'm talking about popular science, that classical popular science about quantum mechanics, that being non-local particles being at the and occupying two positions at the same time. Yeah, of course, Robert. Thank you so much. I wanted to talk about this actually. So many things, so little time. Of course. Every scientist is already presupposing a philosophy. That's why I talk about realism and anti-realism, because even scientists today, when they do science, without knowing it, they are embracing one of the philosophical positions, whether be it realism, anti-realism, operationalism, instrumentalism, etc., etc. Of course, there's nothing without a some kind of prior philosophy. So yeah, thanks for that. Thanks a lot. So everything I wanted to say about quantum theory is that it's the hardest theory to put into words. The mathematics of quantum theory describe a world that doesn't make any sense according to our common sense standards, and I don't know, it gives us a completely new way of looking at reality, a reality that doesn't make sense unless it is somehow interacting with the measurement itself. So it's very complex, and at the same time, it works really, really well. It explains the phenomena. It's empirically it's the most, quantum electrodynamics is the most empirically well tested empirically scientific theory. It corresponds with predictions up until 10 or 11 significant figures. It's ridiculous, actually. But the problem is that once you try to make sense out of the formalism and try to understand what does it tell you about the world at the most fundamental level, you don't understand anything anymore. It's about probabilistic waves that are physical at the same time, not only mathematical. It tells you that matter at the most fundamental level doesn't have any kind of existence like the one that we used to believe in from classical physics and chemistry. What we call materiality or objects do not make any sense. Quine said that there's a withering away of physical objects in quantum theory. The idea of solidity and being, if you will, for physical objects doesn't make any sense at the most fundamental level. And quantum theory, if it tells us something, is that its description of the world at the most fundamental level doesn't make any sense. So there's this whole challenge today in physics and in philosophy of physics in trying to making sense out of quantum theory, not making sense in a commonsensical way, just making sense by trying to understand what does it tell us about the world. Why I agree with Robert. Could be, but for him to be able to come onto the scene, we have to give him the chance, because very few physicists are working on the foundations of quantum mechanics today. And whenever that's what happened to me actually, when I wanted to work on the foundations of physics, I got kicked out into the philosophy department. So we don't have, it's how can I say this? It's career suicide being a theoretical physicist today and wanting to work on the foundations of quantum mechanics, unless you already have your position, right? But if you're young and you want to, I don't know, you want to live, right? You want to make a living, working on the foundations of physics is not the way to go in physics. So you're going to have to go to philosophy of physics, and there we have the same problem that I was talking about again. But there is something about quantum mechanics. It's the most philosophically rich scientific theory ever. It has a lot to say about the world at the most fundamental level, and we do have to talk about it. And when I say talk about it, I don't mean that we have to stop with misunderstood examples like Schrödinger's cat, dead and alive. It's not as simple as that. But what I mean by talking about it is that we have to try to make sense, philosophical sense, about the formalism of quantum mechanics. And we can only do this if we have what Feynman called, what Feyerabend called, excuse me, the physicist philosopher. That's what Bohr and Einstein were talking about. They were rethinking classical philosophical debates about reality, metaphysics, about our knowledge of reality, epistemology, in the light of the new theory that is quantum mechanics. Because making sense out of quantum mechanics would be making sense about what science is, what science can and cannot tell us about the world, and what is the relationship between us, observers, and the world itself. And finally, because I want to take some time to actually discuss all of this, I would have talked about statistical mechanics and thermodynamics, but I won't. I chose to talk about cosmology because we don't talk about it a lot today. Cosmology was, it's very pretentious, right? It's the study of the universe as a system. I think that the idea of cosmology is already philosophical in itself, because the idea that the universe is a physical object that we can study is very, very profound. No one thought about this before modern physical cosmology. If you look at the history of cosmology or cosmogonies, the discourses about the origin of the universe, there has always been this idea according to which the cosmos, the universe, is a container. But in the early 20th century, Einstein, the same Einstein, wanted to apply his theory of general relativity to the whole universe. And his paper was very, very philosophical, seriously, because he already had preconceived ideas about what he wanted his cosmology to be. He had in mind that the universe should be static, it's not evolving, it did not start in time or within time, etc., etc. But the genius of Einstein's 1917 article is that it made out of the universe a physical object that we can actually study scientifically. The universe became a physical object that has a history, it's evolving, it hasn't always been what it is today, and we can actually try to ask questions about that didn't make any sense for any philosopher or scientist before him. The shape of the universe, the geometry of the universe, the topology of the universe, the origin, the age of the universe. Ancient philosophers wouldn't have dreamed of these kinds of questions. And cosmology, it became a science, a very precise science today, observational cosmology. We are making tremendous advancements in better understanding the very, very early universe. But again, once you hit a wall, you start hitting infinities, for example, in your calculations. We call them singularities. Then you have 2 or 3, then 100 popular science books referring to these singularities as being physical things, physical objects, physical events. And that's very dangerous, because usually as a physicist, when you see an infinity in your calculations, you should do anything in your power to, I don't know, to make it go away, because it's a sign that things are not going very, very well. And if you apply general relativity to the very, very early universe, you would need these dreadful infinities. So then you have these popularizers saying that, okay, the universe started from an initial singularity. It's a very dense, infinitely dense point, etc., etc. That's not precise. I don't want to say that this is wrong. I'm not in a place to do so, but that's very, very precise. The hot Big Bang model, and again, I'm not gonna talk, I can't talk about this in 5 minutes. There is a course about the philosophy of cosmology in August. There you go, Mahmoud, once again. This idea that we can actually prove that the universe started from a point, a physical point, then it expanded, etc., etc., is very, very wrong. It's a very bad way of putting into words the beautiful mathematics of early universe cosmology. The hot Big Bang model is a ridiculously powerful model that tells us that the universe a long, long time ago was much smaller than it is today and much hotter. And everything that it has been doing ever since is cooling down and getting bigger and bigger. That's it. Talking about initial singularities as if they were a physical thing, a point, an infinitely dense point that somehow exploded and gave everything, is not precise at all. So when we talk about the universe, and there you go, the article that I talked about when we started, did modern cosmology solve the problem of origins? Why is there something rather than nothing? Very, very, very far from it. Because the Big Bang theory, the Big Bang model is much more a limit of our knowledge of the world than it is a limit of the world itself. So we should be very careful when we study the questions of origins. It's far from being settled. And it's more interesting than ever to talk about it today, because cosmology and cosmogony, the study of the universe and of the origin of the universe, was the philosopher's dream. And now being able to have a precise empirical science that studies the shape and the age and the origin and the formation of the universe is amazing. But we have to be very, very careful when we talk about what cosmology can and cannot tell us about the world. There is still a lot of things to find out. But I think that cosmology is on the right track today, because the fact that we actually have a science of the universe as a physical object is amazing. And again, I want to stress that that's very, very important. Personally, it's important to me because this is what took me into philosophy. I was working actually on early universe cosmology when I wanted to work on the foundations of philosophy, because reading Einstein's paper, in which the foundational paper of modern cosmology, you can't miss out the philosophical preconceptions that Einstein had in trying to develop his own cosmology. And there you go. Here you have another example of how philosophy can be very fruitful to scientific research, empirical scientific research. I'm going to take a second just to read what you guys wrote. Testability before Planck and testability at the end. If you can. Exactly. This is one of the limits that I'm talking about, Jeff. We talk about the Planck scale as if it were something physical that we might be able to go beyond it. We still don't have the theoretical tools, right? Because you'd have to have a quantum theory of gravity. We don't have this yet. And even observationally, there is a limit that we can't see beyond the famous cosmic microwave background. And the fact that we can actually see this is amazing, because it's something that dates from way, way, way back. But there is an observational limit to how far we can go in time observationally, the cosmic microwave background, and theoretically there is this limit that we find that we are facing. And just trying to scrub it off by saying that, okay, the universe starting in a point, etc. This is what I mean by bad philosophy.
What is that the boundary? Is that one of the absolute boundaries between physics and philosophy? Because
yes, yeah.
How can I mean, Penrose has the oscillating, whatever, different types of regenerations, but before t equals 0, we can't test anything. Can't, I mean, and you can't. You don't want to test anything at the end because you won't be around. So I don't even see why the point of excluding philosophy when you have very clear definitions of the boundary conditions that you cannot go past with science.
Exactly. And this is what I was talking about. We have to look at the singularity as it is. It's not a physical object. It's just an expression, a bad expression of the limits of our knowledge about the world. Should we call it quits and say that, okay, we're never going to be able to go beyond that? Of course not. But until now, everything that goes beyond is pure hypothesis. The cyclic universe, the inflationary scenarios, etc., they are pure hypotheses. We have a tremendous observational limit, the CMB, and we have a theoretical limit. So when we want to put into words physics at the Planck scale, we have to be very careful, because we are saying that physics is able to do something that it is not able to do. So yes, of course, the question of origins is still up for grabs. And in my opinion, even if somehow we have a theory of quantum gravity and we go theoretically beyond the Planck scale, the question of knowing why there is something rather than nothing would still be relevant. We're never going to be able to solve it, because talking about it already presupposes that there is something. You have to have something to work with. This is what Leibniz meant. This is why this is the most important philosophical question. We're not waiting for physical cosmology to resolve this question. Of course, it's making it much more interesting. But can we ever resolve it? Why there are laws to begin this? To begin with? I don't think that's always going to be a philosophical question. But in trying to answering it with all our scientific arsenal that we have today, we are making very interesting discoveries, and we are redefining fundamental branches of philosophy like metaphysics and epistemology. So yeah, and I think that's very important, both for physics, fundamental research in physics. Climate scientists, laser physicists, etc., might not be interested in this, and that's not a problem. We need technological advancements. There are a lot of branches of physics that are very interesting, but working at the forefront of theoretical research in quantum gravity, etc., you have to ask these questions, and you can do that by bashing philosophy at the same time, because you would be, as you said, Jeff, much better than I did. You would actually be doing philosophy. So yeah, can I do this, Mahmoud, or that's not the point, right? We're going to talk about all of these in
of course, that's the point of
in the three courses we're offering in April, June, and August, if I'm not mistaken. Space-time and motion from Zeno. Why
you
did
are
that
offering?
Yeah.
I will just be there to take a jab at you as per usual.
Yeah, no, we do need your philosophical insight. Why did Zeno and Parmenides actually think that motion is impossible? They actually had a very deductive argument ready. That's amazing. We're going to talk about Zeno, Aristotle, up until Einstein's relativity. Why the so-called twin paradox is not a paradox, or at least what people think is paradoxical about it is not what is paradoxical about it. Why Einstein thought that he shouldn't have called his theory of relativity the theory of relativity. He should have called it the theory of invariance. We're going to talk about this. Quantum mechanics in June, we're going to talk about what quantum mechanics is, what does it tell us, and what doesn't it tell us about the world? What's the problem with superposition, entanglement, all that rap, Schrodinger's cat, etc. Why we keep saying that quantum mechanics is so weird? So it's a course about what can be said and what should be left unsaid about quantum mechanics. And finally, in August, the course is pretentiously named The Universe. We're going to start with the ancient Greeks, actually, Hesiod, the ancient cosmogonies, this need to always have an explanation of our own origins of the universe, and keep talking about these questions of origins from the ancients until the discovery of the development of modern cosmology in the 20th century, and a couple of questions that comes with: is the universe finely tuned for the evolution of intelligent life, anthropic reasonings, etc. I don't know, that are inevitable once you talk about the universe, and most importantly, our place in it. So yeah, I don't know if I did a good job in convincing you guys that this might be something you're interested in, or yeah, I don't know. So if I don't know if there's something you guys want to talk about, something that you agree, you disagree with, I don't know. We have a.
Thanks, man. I'll let you handle this as I am feeling so. But this was on my end. This was actually quite interesting. So yeah, thanks.
Yeah, I thought it was interesting as well. Thanks for the talk. I was already planning to sign up for the courses as well, so I'll definitely see you there. One thing that kind of relates to like this pop science interpretations of physics that I've been wondering about for a while is this interpretation of the idea of observation in quantum mechanics, and I still don't have a good idea of what it is, and perhaps you know a little bit more about it. I've been trying to look at it at some point, and once I could, it's very hard to find something about it. They just say observation and that's it, and I have no clue what it means. And then once I saw that it's actually a kind of a measurement that's done by interacting particles or something like that.
Yeah, exactly. That's the whole problem.
It changes the whole thing, right? I mean, it changes the whole idea.
I agree. Because all debates around quantum theory today are debates about what we mean by measurement or observation. So see, even the meaning of the words that we are using to formulate the problem are problematic in themselves. So actually the whole course about quantum mechanics is going to be a course about measurement, because mathematically the measurement is very well defined. You apply an operator to that's not important, but mathematically we have a definition of what we mean by a measurement that gives you a precise outcome. But making sense of it on our level, is it the experiment? Is it when the people do it, somehow the human making the experiment plays a role? And this is why consciousness found its way into quantum mechanics, because there is this idea that measurement should involve a conscious person making the measurement, and it was defended by respectable physicists. David Bohm, Roger Penrose today thinks that there's a link between consciousness and quantum mechanics. And so the whole problem with quantum mechanics, one of the fundamental problems, is what we mean by measurement or observation. Is it only a relationship between two entangled particles? Is it bigger yet? The whole universe, there is a quantum mechanical equation for the whole universe, the DeWitt equation. We don't know. So that's what we're going to try to find out. And I feel you, Albert, because it's so hard to find popular science, or at least watered down science books that treat these questions carefully. There are good references, but some are very, very misleading. I do agree. Yeah.
Nice. Looking forward more to the courses then.
Me too. Yeah.
Nadim is asking, where does, well, first off, Bob again is saying, I still don't see how a scientist can disavow philosophy. But I'm curious about the courses. I answered this. I would like to also add a few things. The issue is not so much to engage in philosophy or do philosophy as such. The fact that they intentionally disavow it, even though unconsciously, makes them repeat the same mistakes, I think. I don't know if this makes sense. Like some analytic philosophers, if you don't know your history, you end up engaging in the same debates time and again. So maybe they could just save time by reading a book or two about philosophy, and things would be much easier for them. I don't know what you think, Philippe.
I totally agree. I totally agree with what Robert said. Is for me, I really can't see with everything we've learned from modern physics, how can you actually not see very clearly that what you're engaging in is actually philosophically very, very interesting? Yes, and we keep doing the same mistake. And answering Nadim's question, I don't know. No one knows. Where does mathematics come into this? Eugene Wigner, he's a physicist who worked on quantum mechanics, wrote a paper And its title is very, very telling. It's called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. The only thing we can say about mathematics is that it is unreasonably effective in describing the physical world. Why is it so? Maybe because mathematics have some kind of independent existence. The universe is essentially mathematical. I don't know. I think both positions are hard to defend. Mathematical Platonism has its upside, but again, saying that mathematics are invented, or this tool that we invented in order to be able to make sense of the world, I don't know. I really don't have, no one does have an answer, but let's say that there is something about it. The fact that a theory like quantum mechanics is essentially mathematical, and it is so powerful at explaining the world and giving you something as, I don't know, as technologically important as the laser, for example, which it's because of quantum mechanics that we are able to have this conversation right now. And the only thing we understand about quantum mechanics is its mathematical structure. So makes you wonder.
Before Henry asks the question, I'll read it out loud for those who might be watching this later on. Alexandra, nice way of putting things in perspective. It seems to me the crisis of this clash of disciplines extends itself beyond physics and philosophy. Education and neuroscience is one example. There is discomfort in exploring the space between spaces or disciplines. Back to the topic, how have you experienced the tension between physics and philosophy translates itself in how?
It was a bit messy.
Yeah,
it was a bit messy because I was writing two questions at the same time.
How have you experienced the tension between physics and philosophy? And what's the other question?
No, it was the same, but I decided to change it, then it automatically sent it. So the idea is to have a bit of a deeper look into how you personally, tangibly experience this clash between physics and philosophy. Very curious to know how it translated.
Well, academically, in my opinion, on a social or popular level, it's very, very clear this wave of I don't know, reducing philosophy to theology and trying to say that science proves that this is bullshit. But I'm not even going to talk about this. But academically, you can actually see it in theoretical physics departments, for example. There is this I don't know how am I going to put it, this malaise. Physicists think that physics is in a rut, has been in a rut for the past 20-30 years, especially after the LHC didn't make any new discovery that we were expecting: supersymmetry, supergravity, hidden dimensions, etc., etc. So there is this malaise again in theoretical physics because the LHC is this huge particle collider that the Europeans built between France and Switzerland. Again, the states wanted to make an even bigger one, but it failed at Congress. Anyway, it's a very interesting story. But so I think this clash between physics and philosophy in practice is, you can see it very clearly in physics, in theoretical physics departments, because I've seen it firsthand, actually, because you see these guys asking philosophical questions. What is space? What is time? Can we go beyond the limits of our knowledge, of our scientific knowledge of the world? And at the same time, still bashing their colleagues in philosophy or physics department as doing something that is meaningless. Even though they are asking the same questions, they are interested in trying to better understand what science tells us about the most fundamental concepts of our world. And I don't know how I'm going to put this, but for them, they think they are doing a better job because they are working within the scientific method, even though we all know that we don't know whether there is a scientific method today, because you have some physicists that claim that string theory, for example, is not scientific because it's fundamentally untestable. And the others saying that, no, actually, your definition of science is completely wrong because we have to go to what we call today a post-empirical science. These are physicists actually saying the words post-empirical science. This sentence is a philosophical monster. And it fits right into the philosophical tradition of Popper and Kuhn and Lakatos, etc., etc. And you actually see this tension. It shouldn't be a tension. Exactly. We should just not think of. And a lot of philosophers of physics see philosophy of physics as being a natural continuation of physics itself. But the departmentalization of the disciplines is becoming very, very obviously bad for both disciplines. And the fact that we still have a department of philosophy, in my opinion, is ridiculous today. What does it mean? And Mahmoud knows this much better than I do. What does it mean to be a philosopher? What are you working on? Are you interested in ethics, in morals, in theology? Or are you asking questions about metaphysics and epistemology? Because these things are radically different. And practically or academically, and educationally on a much smaller scale, take high schools, etc. It's very, very bad. Because if you take, I don't know, the French educational system, I'm going very, very far, but it's one of the best because they still have philosophy at the high school level. You still have this idea according to which philosophy is part of the humanities, right? It's a continuation of literature, etc., etc. And you have the hard sciences. That's very bad for both disciplines. Yeah. So I don't know if I answered your question, Alexandra, but yeah, I don't know.
Before Jeff, Henry had a question.
Oh yeah, I'm sorry, you had your hand. Yeah.
Oh yeah. So yeah, definitely. Thank you so much, Philippe. I like that example about the failed collider in the U.S. And kind of my question is, what are your thoughts about the ethics of a call or demand for efficiency in science? So from the perspective of the public, and sometimes this is called the replication crisis, although I don't prefer that term. But what do you think about all that? I mean, I can see this. I mean, I tend to be sort of in favor of that, but I want to.
You mean about the transparency between scientific research and the public? I didn't quite get that.
Well, maybe not so much transparency, but sort of like if we spent the money for this collider, what are we getting out of it?
Exactly. That's a very tough topic, because when I was younger, I didn't pay any taxes, right? I was a PhD student. I thought that it was ridiculous. It was ridiculous because. And you probably know the story better than I do. You had this, good things were going on. In the States, you had the bomb, the space race, and now you have the particle collider. You'd be on the right track and finally imposing yourself as being the scientific, powerhouse. So when I was younger, I would say, because I've read Steven Weinberg's book, it's mainly about the superconducting super collider and about how he actually, he had a testimonial before Congress trying to persuade them that it should be done. So when I was young and more scientific, etc., I said that was dumb, actually, voting down something that important. But now I'm getting personal, but it's the only way I know how to answer this question. If you ask me the question today as a classic, I don't know, your typical taxpayer, telling me that you want to build a very large hadron collider in order to better understand the structure of the universe and better understanding the evolution of the universe, that wouldn't do it for me. You have to give me something more. And I think the problem is that scientists in popular circles they are only relying on the magic of science, as if they were addressing youngsters like myself when I was young. Because when I was young, you could have told me the origin of the universe, shit like that. I would have said, yeah, that's so cool. But you know, when you're a working man, I think they should have focused more on the fact that sometimes when you are researching elementary particles, that can lead us to have technological advancement that we wouldn't have dreamed of. And I think that this is what we should be focusing on when we try selling these ideas to the public. It's not only about the magic of science and of discovery. Let's get real. But at the LHC, for example, now there's this whole section that studies medical imaging, etc., using elementary particles. So here you have a theoretical discovery that has nothing to do with technology that turned out to be actually very, very important for the, the development of medicine, for example. So sticking with black holes, the magic of discovery again, etc., is not going to do it for science, in my opinion, especially with everything that's going on today, right? And you don't want, and people got scared with the collider, even with the LHC, which was in 2010. You started hearing voices about some kind of black hole forming in Europe, and okay, these are stupid, but people think about this and they are scared. If you say nuclear today, everyone is scared. They don't even know that it's mostly green energy, right? So how about if you're talking about something that's that far away from society as elementary particles? It's a very, deep down, I think it would have been great for the United States if they were able to build this collider, even for physics, because we would have settled this debate 40 years ago. But I don't know, it is what it is. But I totally understand, I totally get and agree with you that there's this whole ethics of scientific research and scientific communication that has to be developed more, yes. And this is why you have some universities, actually, they have courses called Physics for Future Presidents and Physics for Poets, etc. We need this more. We need more scientifically informed decision makers. That's important. Yeah.
Thank you.
Thank you, Henrik. Thanks. Thanks a lot.
So you're the 3 parts. Can we take the classes? Are those individually, or are they part of the whole thing?
Of course, separately, and they're independent actually, but each treats with a different set of questions. Yeah.
Okay. And so the final one, I mean, it seems like that would deal with the thing that I'm trying to grapple with in practicality. When you have Harris and Dawkins, these guys are not dumb. And I don't think they're just selling books. How is it possible that, and will you steal, in the class, or not, I'm not trying to get a freebie answer, but how do you steel man what they're saying to have ultimate faith in these, what I like the boundary conditions, and that what we don't know, they just assume and extrapolate that we can know, right? I mean, that's, and I don't see any evidence that there's no evidence-based science that proves that we can know, right?
I agree, and the problem is, Jeff, is that whenever you think you know, you will still, you can still find even more questions that I don't know, because, and that's it, because I think these guys are not dumb. I keep talking about Dawkins in my other courses, because when he was younger, his first books about biology, they're really first-class popularization of science, in my opinion. The Blind Watchmaker, the Selfish Gene, etc., etc. But I think the problem here is not between science and theology or metaphysics. The problem is that when they talk about origins, they mean a different thing. The words mean different things for these guys than for other philosophers, maybe. So, and this is why the last lecture is called about the hot Big Bang and the limits of our knowledge, because I think they are confusing the limits of our knowledge with the limits of the world. And I completely agree with you that today nothing tells us that we actually can know. But they keep saying that if you say this, it's like you're you're saying, okay, let's stop there, presuppose that God exists, there you go, you have your question. But that's not what scientists are, philosophical scientists are trying to do. We are going to keep pushing the boundaries, but that doesn't mean that there is an empirical answer for the question of the origins and the knowability, the knowability of this origin, because that's the whole other problem. Can we really be able to understand something that is, I don't know, you hear discoveries about a black hole that makes 10 million solar masses. It's easy to put into words, but it's not something that we can start to grasp, let alone the origins of everything. So yeah, I wouldn't have an answer, but what we're going to be trying to do is to show as clearly as possible what cosmology, physical cosmology, general relativity can tell us about the origin of the world, and most importantly, what it cannot tell us about the world. Yeah, I don't know if
you did have an
answer.
Thanks, man.
If you did have an answer, our Ponzi scheme would die out.
Exactly. Thanks. That was so much fun. I think the courses are going to be fun too. They're fun to prepare. That's for sure.
Yep. Thank you very much, everyone, for joining today. I hope you enjoyed. I hope you learned a thing or two. And as I said, I'll be posting the thing on YouTube and sharing on Twitter, and we'll send you an email. Or Unlearned, yeah, or Unlearned.
That's even better.
I hope you, yeah, but thank you, Ines. Thank you, Anne Albert. Thanks. And have a good evening.
Thank you, guys. Cheers. Thanks.
Ciao.
Cheers.
Good night.